I am asked to solve an exponential equation. 27 times 1/3 raised to 3 minus 3x equals 27 raised to x. I'm going to begin by writing down the equation given. 27 times 1/3 raised to the power 3 minus 3x equals 27 raised to x. It might be tempting to reduce 27 and the 3 and just write 9 raised to 3 minus 3x, but note that there's parentheses around the 1/3. Only the 1/3 is being raised to 3 minus 3x, not the 27. So you can't multiply the base by 27 if there's an exponent on it. All right, the first rule I'm going to apply is rule 4. I'm going to note that the reciprocal of 1/3 is 3 over 1, or 3, which is a whole number. So that's nice. That'll allow me to get rid of fractions. So I'm going to apply rule 4, which says a fraction raised to a power equals to its reciprocal raised to the opposite of the power. So the reciprocal of 1/3 is 3 divided by 1. The opposite of 3 minus 3x is negative of the whole quantity 3 minus 3x. And I'm going to put parentheses around the whole quantity 3 minus 3x. And then the rest of the terms kind of stay the same. I'm going to simplify. 3 divided by 1 is 3. If you distribute the negative 1 times 3 is negative 3. Negative 1 times negative 3x is positive 3x. The next thing I'm going to notice is that I have 3 bases, 27, 3, and 27, and they're not the same. All right, 27 is a base if you think of it as 27 raised to the first power. So I'm going to rewrite 3 and 27 as numbers with base 3. Remember that 27 is 3 times 3 times 3. So 27 becomes 3 cubed. 3 stays as 3, and 27 on the right hand side becomes 3 cubed as well. Notice I put parentheses around the 3 cubed. Alright, there's a few things you can do next. On the left side, notice that you're multiplying powers with the same base, with base 3. So I'm going to apply rule 5, which says if you're multiplying powers with the same base, you keep the base, you keep the 3, and you add the exponents. So I'm going to write 3 raised to, and add the exponents. 3 plus negative 3 plus 3x. Notice that the 3 didn't become a 9. You keep the base as 3. Alright, I'm going to simplify on the left-hand side. 3 plus negative 3 is 0. So on the left side, you just have 3 raised to 3x. And then on the right side, you have a power raised to a power. 3 cubed raised to x. So I'm going to multiply the powers, the exponents. So I'm going to get 3 raised to 3x equals 3 raised to 3x. From this point on, you can kind of tell that you have an identity. You have a left side that's identical to the right side. But let's say you didn't notice that. You can make a note of the fact that the bases are the same and equate the exponents. 3x equals 3x. Subtract 3x from each side, you get 0 equals 0. This is a special case. It can happen anytime you're solving an equation. What happens is all the variable terms fall out and you're just left with a number statement. At this point, you have to evaluate whether that number statement is always true or always false. 0 is always equal to 0, so this is always true, which means that the solutions are all real numbers. It means that any value you plug in for x is going to make the equation true. So the solutions are all real numbers. Okay, example 6 is our last example, problem 6. So in this case, you are given an exponential equation, 81 times 1/9 raised to the quantity 1 minus 3x equals 81. Now, instead of being asked to solve it, you're being asked if a particular value of x is a solution. Is x equals 2/3 a solution? Checking if something is a solution is a useful skill to have when we're checking whether the answer we have is correct after solving an equation, or like on a standardized test, if you're given a multiple choice where you have a few choices for a solution, it's nice to be able to plug them in and see which one is the correct answer. If you remember, in order to check if x equals 2/3 is a solution to the exponential equation, we're going to substitute 2/3 for x. If the resulting equation is true, then x equals 2/3 is a solution. I'm going to begin by writing the original exponential equation. 81 times 1/9 raised to 1 minus 3x equals 81. Notice x appears only once in the exponent, right? That's why it's called an exponential equation. I'm going to substitute 2/3 for x. So 81 times 1/9 raised to 1 minus 3 times 2/3 equals 81. And then because I haven't really evaluated whether this number statement is true or not, I'm going to put a question mark over the equal sign. All right, I'm going to simplify. 3 times 2/3 is 2, right? It's 6 divided by 3 or 2. So I'm going to get 81 times 1/9, 1 minus 2 on the left side, and on the right side I'm going to have 81. And again, I don't know whether that's true or not yet, so that equal sign has not been verified yet, so I'm going to write a question mark over the equal sign. All right, I'm going to simplify further. 1 minus 2 is -1. So I'm going to write 81 times 1/9 to the negative first power on the left and 81 on the right. One ninth to the negative first power is 9 over 1 to the first power, or just 9. So I'm going to apply rule 4 in this case. So on the left side I have 81 times 9. On the right side I have 81. And then you can see right away that's not going to be true, right? Multiplying 81 times 9 is not going to give me 81. But if you want, we can multiply the two numbers on the left side. 729 equals 81. And that, of course, is a false statement. So that's a false statement. So what that means is x equals 2/3 is not a solution to the exponential equation. And we weren't asked to solve this, so all we were asked is to state whether a given value is a solution or not, and we found out that it wasn't, so we can stop here. All right, now go ahead and try a few of these problems on your own. The problem set is due for my B-Day classes on March 23rd by 10 a.m. and for my A-Day classes on March 24th by 10 a.m. I'm available from 9 a.m. to 4 p.m. for questions, either through email or through Schoology. And then you can submit a photo or a scan of your work through email or through Schoology as well.